Okay, good day ladies and gentlemen. Today we're going to talk about another type of encoding. We're going to talk about Huffman encoding, and you're going to learn how to run the algorithm, and you're going to learn how to calculate the file size. Okay, so when we have an image, we usually put all of the colors in a fixed length field. So we have the same number of bits that identify every single color. What a Huffman algorithm does is it uses a different number of bits to identify each color based on how frequently that color is used. So here we have an example image. We've got red, green, blue, black and white pixels. Each one has a color code assigned to it. And then the frequency column tells you how many pixels there are of that color. So there are 1,000 red, 500 green, etc., etc. So because each color has a 3-bit color code, we can say that the frequency times the number of bits is the total number of bits for that color. So there are 1,000 pixels for red. Each pixel takes 3 bits, so it's a total of 3,000 bits for the reds. And altogether, the file size is going to come to 5,500 bits. So this is the Huffman algorithm. It's 4 steps, and it's just a loop that goes round and round until you're done. And I'm not going to go through the step in too much detail now. We're going to work through the steps one by one in the next couple of slides. So the first step is to identify the 2 colors that are used the least. So in this case, black is only used with 100 pixels, and white is only used with 50. The next step is going to be to create what we call a summary node. And a summary node is just a placeholder node, which we're going to call S1. And underneath S1, we're going to write the sum of the 2 frequencies. So the 150 underneath S1 here relates the 50 from white and the 100 from black. The next step is to make sure that the lowest frequency node is always on the left. Okay, so in this case it already is, so the white is less than the black, so we make sure that the white goes on the left hand side of the tree. Finally, we're going to replace the 2 colors that we've used, so in this case white and black, with our summary node. So we go back to our table, we remove the white and the black, and we put the summary node in. So now we have red, green, blue, and our summary node. And now we return back to the first step, which is to identify the 2 least frequent colors, including our summary node. So in this case, it's going to be the blue and the S1. So now we make a new summary node called S2, which includes our old summary node, S1, and the blue node, and has a total of 350 different pixels. Once again, we check that the lowest frequency node, in this case S1, is on the left-hand side. And then finally, we place the summary node S2 back into our color code table, replacing the S1 and the blue nodes. So once again, we identify the 2 least frequently used colors. We create a summary node, making sure that the smallest node is on the left hand side. Then we place the summary node back into the table, and we start the loop again. Identify the 2 least used colors, create a summary node, make sure that the least used is on the left, and then put the summary node back into the table. And now that we've only got 1 summary node, we can stop building our tree. Once we've built our tree, now we can label it. And the way that we label it is by saying every time we go left, we're going to add a 0, and every time we go right, we're going to add a 1. So S3 becomes 0, S2 becomes 0, 0 because we've gone to the left, S1 0, 0, 0, and then finally white becomes 0, 0, 0, 0. And then we can see that we've gone for green, we go left 1, so that's 0, and then we go right 1, so that becomes 1. Code for green becomes 0, 1. Finally, we put the color codes back into our table so that we can see that red, instead of being 0, 0, 0, now becomes just 1. Green becomes 0, 1. Blue becomes 0, 0, 1. Black 0, 0, 0, 1. and white 0000. Okay. Now when you recalculate the size of the file, because our most frequently used color has now got the shortest code, we have dramatically reduced the size of our file. So red now is going to use a total of 1,000 bits, because red is going to use 1 bit per pixel. There are 1,000 of them, and it's going to use so it's a total of 1,000 bits. Green is 2 bits per pixel. There are 500 of them, so it's going to produce a total of 1,000 bits. And when you recalculate all of this, the file size has now fallen from 5,500 to 3,200 bits, simply by changing the number of bits we use based on the frequency of the color. Okay, so Huffman is one of the most complicated algorithms you're going to come across, probably ever. So we're going to put a lot of practice into this over the next couple of weeks to make sure that you've nailed it. There's always a few marks on the exam. It's definitely going to come up. And so yeah, we'll just go through about 1 million of them until we can all do them perfectly. Okay, talk to you all soon.